In this video, we're going to talk about Ohm's law. So what is Ohm's law? Ohm's law describes the relationship between voltage, current, and resistance. Perhaps you've seen this equation. V is equal to I times R. V stands for voltage, I stands for the current, R is resistance. Voltage is measured in the units volts. I, which represents the current, is measured in amps. And R, the resistance, is measured in ohms. Now, you need to know that as the voltage in a circuit increases, the current will increase, provided that the resistance stays the same. If the resistance goes up, the current will go down if the voltage is held constant. So voltage and current, they're proportional to each other, and resistance and current, they're inversely related to each other. Now let's work on a practice problem. Let's say if we have a 12-volt battery connected across a 4 ohm resistor. What is the current flowing in this circuit? Conventional current flows from the positive terminal of the battery to the negative terminal of the battery. This is the opposite direction to electron flow. So to find the current in this circuit, we can use Ohm's law. V is equal to IR. So the voltage is 12. We're looking for the current. The resistance is 4. So we need to solve for the variable I. Let's divide both sides by 4. 12 divided by 4 is 3, so the current is going to be 3 amps. Now let's say if we have 3 resistors connected in series, like this. Let's say this is R1, R2, and R3, and it's connected across a 60-volt battery. Now let's say that R1 has a value of 3 ohms, and R2 is 4 ohms, and R3 is 5 ohms. So what is the current flowing in this circuit? In order to find the current flowing in a circuit where the resistors are connected in series, you need to find the total resistance. And the total resistance is going to be R1 plus R2 plus R3. You just need to add the values of the 3 resistors. So 3 plus 4 plus 5, that's going to give us 12. So the total resistance in a circuit is 12 ohms. Next, you need to calculate the current. So we could use the formula V is equal to IR. So V is 60. That's the voltage across the 3 resistors. We're looking for the current, and then the total resistance is 12. So you can treat this as if it's one big resistor, and you have a 60-volt battery source across a 12 ohm resistor. What is the current in that resistor? So what we need to do is divide both sides by 12 to get the current by itself. 60 divided by 12 is 5. So we have a current of 5 amps flowing in this circuit. Now once we have the current, we can calculate the voltage drop across each resistor. What is the voltage drop across the first resistor? Now in this series circuit, the current that flows in a circuit is the same as the current flowing through R3, R2, and R1. Because it's only one path for the current to flow, it's going to be the same, 5 amps. So to find the voltage across the first resistor, we can use the current that flows through the first resistor times the resistance value of that resistor. So we're using Ohm's law, but in a different way. I1 is going to be the same as I, because that 5 amp current is flowing through each resistor. But R1 is different. R1 is going to be 3. So it's 5 times 3. So we have 15 volts across R1. Now what about across R2? what is the voltage across R2? Well, we could follow the same pattern. So we could say V2 is equal to I2 times R2. So the current is still going to be 5 amps, but this time the resistance is 4 ohms. So 5 times 4, that's going to give us 20. So we have 20 volts across R2. Now across R3, it's going to be V3 is equal to I3 times R3. So I3 is going to be the same as I2 and I1, so that's 5 amps. R3 is 5, so 5 times 5 is 25. So notice that if you add up 15 plus 20 plus 25, it gives you 60. And so the voltage of the battery is equal to the sum of all of the voltage drops across those resistors. And there's something called Kirchhoff's voltage law, which basically states that as you go around a circuit in a loop, the total voltage will be 0. And it makes sense because the battery, it increases the energy of the circuit because it supplies energy to the circuit, so it increases it by 60. The resistors consume energy from the circuit, so they decrease it, thus they have a negative value. So if you add up positive 60 with negative 15, negative 20, and negative 25, you get 0. Because the energy that flows into a circuit must equal the energy that comes out of the circuit. Thus, Kirchhoff's voltage law. It always applies whenever you have a closed loop. So the sum of all the voltages in a closed loop will always add up to 0. Now what's going to happen if we connect 3 resistors in a parallel circuit? Let's calculate the current in such a circuit. In a series circuit, the current flowing through the resistors that are connected in series is the same because the current only has one path in which it could flow. In a parallel circuit, the current has multiple paths, and so it could vary. However, notice that whenever resistors are connected in parallel, the voltage across those resistors is the same. So let's say if we have, in this case, a 12-volt battery. Each resistor is connected across that 12-volt battery. And so all of them have 12 volts across their terminals. So let's call this R1, R2, and R3. And so let's say that R1 has a value of 3 ohms, and R2 is going to be 4 ohms, and R3 is going to be 6 ohms. What is the current flowing through each resistor? So we can use this formula. V1 is equal to I1 times R1. So remember, in a parallel circuit, the voltage across the resistors connected in parallel is the same. But in a series circuit, the current flowing in the resistors that are connected in series will be the same. In this case, V1 is 12 because we have 12 volts connected across R1. And to find the current flowing through this resistor, we need to use that formula. R1 is 3, so the current is going to be 12 divided by 3. So we have a current of 4 amps flowing through R1. Now let's do the same for R2. So let's use the formula V2 is equal to I2 times R2. It's basically Ohm's law but with different subscripts. So V2 is still 12 and R2 is now 4. So it's going to be 12 divided by 4, which will give us a current of 3 amps. Now to calculate I3, it's going to be 12 divided by 6, following the same pattern, and so that's a current of 2 amps. Now, notice that as the resistance increases, the current decreases, as we mentioned in the beginning of this video. Here, notice that R1 has the lowest value and it has the highest current. R3 has the highest value, but it has the lowest current. So as you increase the resistance, the current decreases. If we increase it to 6, the current decreases to 2. And if we decrease the resistance, the current will increase. If we decrease it to 3, the current goes up to 4, provided that the voltage is held constant. And so you'll see this relationship in a parallel circuit, as you can see it here. Or in a series circuit too. You could see that relationship there as well. Now, what is the current that leaves the battery? How can we determine the current that's leaving the battery? The total current in the circuit, which we'll call IT, that leaves the battery, is going to be the sum of the individual currents. So it's going to be 4 plus 3 plus 2. 4 plus 3 plus 2 is 9. So the total current here is 9 amps. Now let's focus on this point. What is the current that is flowing through that branch? Right here, along, let's say, this wire. What is the current in that region? So now we need to use something called Kirchhoff's current law. We saw in the last example that Kirchhoff's voltage law, which basically states that the sum of all the voltages around the loop adds up to 0. Well, Kirchhoff's current law is very similar. The current that enters a junction is equal to the current that leaves a junction. Now let's draw a picture. So we have 9 amps of current flowing to this point, and we have 4 amps that's leaving it. Now the current that is flowing to a junction must equal the total current that is leaving a junction. So we have to have current leaving in this direction, and it has to be 5 amps because 5 plus 4 is 9. So we have a total of 9 amps of current that enters this junction and 9 amps of current that leaves it. And so that's the basic idea behind Kirchhoff's current law. So we have 5 amps flowing to the right in this direction. Now out of those 5 amps, 3 amps is going this way. So that means the other 2 amps flows in this direction. And you can see how it's like a river splitting off into 3 directions. So in this section, we still have 2 amps of current that's traveling here. And then when it joins up with a 3 amp current, 3 and 2 will add up to 5. And so we have 5 amps flowing in this region. And then the 5 and 4 will get together. And so we're going to have a total of 9 amps of current flowing in this region. And so as you can see, the current that's going this way is going to be the same as this current here, 9 amps. And so hopefully this all makes sense. And so I want to give you a basic idea of how to use Ohm's law in a simple circuit, in a series circuit, and also in a parallel circuit. So that's it for this video. Hopefully you found it to be helpful and it gave you a good understanding of Kirchhoff's voltage law and his current law as well. Thanks for watching.